that, but there are really good things about Lightning, things that work very well now, and things where Lightning fulfill its promises, and things that don't work that well and could be improved. So what is really good about Lightning is you own your. It's true to the Bitcoin vision of what money and payments should be like. You own your coin. Your It's as private as possible. Privacy in Lightning is better than on Bitcoin. Actually, you get instant payments, and fees are proportional to the amount you pay, which means you can really have micro payments that have not been possible on chain for a long time. There are things that are worse with Lightning than with Bitcoin, and onboarding right now is not too good. There are UX issues like how do you provide balanced information to users? Do you split on-chain and off-chain? How do you get inbound capacity? How do you sync with the network? And you need to sync with the Bitcoin network to make sure that your channel still exists. You also need to sync with the Lightning network to get a good view of what the network looks like. And there are things we'd like to do, like spontaneous payments, that are not there yet. And there is also a really bad UX problems when Lightning doesn't work. So who has already used Lightning to buy things? Okay, good. Really good. So one of the first problems with Lightning for newcomers is onboarding. How do you get started? And it's pretty high to hide complexity right now. Who is using our own wallet, Eclair, on mobile phones? Okay, just a few people. We try to make it as simple as possible, and everybody says it's too complex. That we have off-chain, on-chain balance. You need to create channels. Most people don't really understand what a channel is. You need to have Bitcoin. So getting to like, for example, if you want to make a demo with people who don't know much about Bitcoin and Lightning, a few years ago we would tell them, okay, just download any kind of wallet. Now they have one. Show me your QR code. I'm going to send you Bitcoin, and you can send them to your colleagues, and this works pretty well. With Lightning, it's much more difficult. You need to download a wallet. You need to have Bitcoins. If you don't have Bitcoins, you can't open channels. You need to choose who you open your channel with, and this is not easy now. So the option we propose, like the basic option we set on our own wallet, is you open a channel with us. But basically, we've seen that people open a channel with us or with 1ML or some of the big nodes, but it's really hard to know where to start. And a lot of people are working on ranking systems for Lightning nodes, but I think they're pretty much not open yet, and the criteria they use to rank nodes are pretty vague. Um, Basically, what you can use is how old the node is. All nodes are supposed to be reliable, and how much capacity there's on a node. The idea is if there's a lot of bitcoins on a particular node, it means it's probably reliable and it's probably usable. But there are no good criteria for deciding what to do, and mistakes are costly. If you open a channel that doesn't work, it's gonna get closed. You're gonna lose your on-chain fees, and you have to start all over again, and it's a pita. You also need to wait until your channel is active. So it means if you don't have anything, you need to receive Bitcoin. You need to wait for the Bitcoin transaction to be confirmed. Then you open your channel. You pay a fee, and you have to wait. You have to wait for the channel to be confirmed too, and that's a bit of a problem. So what we saw on mainnet was users who start with really tiny amounts, like a few dollars, which is not such a good idea when fees rise up because you end up with off-chain funds that are worth nothing. Everything is going to be used to pay for fees, and that's also created a surprise and disappointment. So all the tiny channels are gone now, but you still see people opening like channels for a few bucks, and it just doesn't make sense now. So the problems we see with onboarding is how you start from scratch, how you choose where to open channels. And there's something else that you see when you open a channel. How do I receive money? Today we have single funded channels, which means if you download a wallet and open a channel to anyone, you can pay, you can't receive anything. And at first, we thought it was not too much of a problem because most end users will be paying for things most of the time, would not be receiving money. But it's something that we've been asked to implement for a long time, and it was not really a technical problem. What is the big issue when you want to receive money? Yes. It's not a technical issue. It's not an issue of you need to watch the blockchain. Who is going to be willing to lock funds into a channel they open with you? And why would they do that? That's the biggest issue. So it took us a long time to provide the ability to receive funds on our mobile wallet, not because we didn't know how to do it from a technical point of view, but because we didn't know how to have a good enough solution for providing inbound liquidity. And this is something that is, I wouldn't say it's a huge problem now on Lightning, but everybody is working on solutions for providing liquidity. You have lots of new liquidity providers. Basically, you have lots of services where you will pay for people to open a channel back to you with different options. One of the problems for new users is how do you manage your balance? Basically, if you want to build a Lightning wallet, you have two options. You show one single balance with everything, or you start splitting. You show an on-chain balance and an off-chain balance. But off-chain balance is not enough because you need to know what you can send and what you can receive. The limitations of Lightning today is you can't send more than what you have. And if you want to receive money, you can receive more than what is on the other side of your channel. So do you explicitly show this to users or don't you? If you do, then it becomes really complex. But if you don't, then people can't receive money and then they don't really understand why. That's actually really confusing. And there are lots of expert features that you can find in wallets, like how do you select your UTXOs? How do you manage fees? What kind of address do you want to show Bec32? Blah, blah, blah. And this quickly gets also even more confusing for newcomers. Do you want to use mixers, services, or CoinJoin? I think Wasabi and Samurai have kind of integrated mixers with them. It makes the whole thing even more complex and really hard to understand for end users. But one of the biggest problems that we saw a few months ago was the inbound capacity issue. You've managed to open a channel to someone and you say, okay, cool, I can send money, can I receive money? And very surprisingly for most users, no, you can't receive anything. So what do? And it turns out a lot of people have started providing liquidity services. There's us. There's Thor, I think that's Bitrefill. There's Loop, I think it's Lightning Labs. And the idea is basically always the same. You pay for people to lock funds in a channel they open back to you. And this is probably the first traditional business that was ported to Lightning. A lot of companies want to use Lightning to kind of rent Bitcoins to node operators and make interest by having services such as liquidity services and users to pay for them. We may have dual funding soon. I won't say why. It may, from a technical point of view, it looks like it's a solution for the inbound liquidity problem, but it's not because, again, the problem is not a technical issue. Even if you had dual funding, if I want to open a channel with you, how do you decide that you want to lock some of your funds in that channel? That's not a technical problem. It's an inbound liquidity problem. Suppose you say, I'm going to advertise that I'm going to open back a channel to every users that's connected to my service. Suppose you have like 50,000 users show up. What do? You will either run out of liquidity, or it doesn't make much sense right now. So how payments work on Lightning, I think everybody knows. So I'm going to be really quick. You want to buy something on a website, they will show you a QR code that includes the destination, the amounts, and the payment hash and expiry, and your wallet will locally compute a route to the destination, create an onion packet, forward HTLCs. Vendor will receive the HTLC with the payment hash that he knows. It will return the pre-image, and you've paid. This is really good when it works. It's instant and it's awesome. But for this to work, you must have a good enough view of the network. It's really easy when you run servers that are online most of the time, but what if you use mobile wallets that are offline most of the time? That's things you start your you open your wallet, Lightning wallet every 5 minutes every day, or just when you want to pay. How do you synchronize in a few seconds and have a good enough view of the network that you know that your payments will work? That's quite a difficult problem. So our goal, we want the mobile app to be usable within a few seconds. It's off. You start the wallet. Within a few seconds, you have checked the blockchain. You have updated your view of the network, and you can start paying. And this is really, really hard to get right. And you must remember that you also need to monitor the blockchain. You need to make sure that the channels you have not been closed. And these two means that you need to synchronize, you need to catch up on the state of the blockchain. If you've been offline for a few days, it can be a bit tricky. So that's also a UX issue. Things that people have been wanting to do for a long time that are hard to get right are spontaneous payments. So there are lots of ideas that have been proposed, like include the pre-image in a payment request. I think what we have, the idea we have now is that, I think Christian explained this yesterday, you use the shared secrets in the onion to basically make a payment that the sender can guess. The sender can guess the pre-image. That's, I think, a pretty good solution. And it's something that can be more or less reused for offline payments. That was also something that I think we mentioned before. It's a very common request for people. How do I use Lightning if I don't have an internet connection? And the idea is the same. You use ECDH tricks to compute a pre-image that's your own node. The node that belongs to the company that is running the vending machine will know how to guess using a fake channel ID. This, I think, is quite nice, and it kind of solves the offline payment problem. Basically, you use your user's internet connection instead of yours. But there are things that are really bad, and one of the things that is really bad with Lightning, and it's because it was designed this way, is error feedback. I'd say that in many ways, Lightning was designed to be almost impossible to debug. And when things go wrong, you don't have much to show your users. When things go wrong, they don't know anything, and it's very frustrating. And if your product is a wallet, you get hit by unhappy customers because the payments are failing and they don't know why. All you can say is, well, we don't really know why too, and it's a bit frustrating. And there are things that are really not obvious for payment system, like when your payment is stuck, it may go through after a while. You can't start again. It's much better now, but maybe not a few months ago, but last year, a lot of services would happily send back the pre-image for payments that had been expired for a long time, or for payments that had been done again. They would not remove the pre-image for their pending payment database, and that was really, 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 really bad. So the problem with the error feedback on Lightning is this: you've sent an HTLC, it's supposed to go to C. It goes to C, and for some reason C never replies. what happens now? What happens is your payment is stuck. And it can be stuck for days. And there's nothing you can do. On the sender side, there's absolutely nothing you can do. You need to wait. If you try to pay again, you may pay the same thing twice. And again, a lot of people will not check this because it's not part of the protocol. If your channel is closed, you will get your money back, but you need to pay an additional on-chain transaction. It's not too good. And there's a kind of, today, there's a kind of, the incentives for closing channels, for forced closing channels, are a bit weird because Lightning is not symmetric. I don't know if you remember, but in my transaction, my output has a delay. Yours doesn't. So I wouldn't say it's on purpose, but we see that sometimes implementations delay the moment whether we publish their own commitment transaction in the hope that you will do the same first. Because if I can get you, if I have a channel with you, if I can get you to publish your commitment transaction, I will get my money back right away. If I have to publish mine, I need to wait, which is a bit of a pain. So there's some you see a kind of weird race to be the slowest, to not publish your commitment transaction first, which is a bit strange, and which is fixed with L2 again. The rest you've seen. So basically, the two biggest issues we have on Lightning, in my opinion, are first stuck payments, and then quickly synchronizing your view of the network. But for stuck payments, where is it? Actually, a lot of people have just recently, like in the last few days, came up with the same idea expressed in different ways, but basically, this doesn't work because C is the only one who knows the pre-image. So once your outgoing payment is committed, you need to wait because it may go through. But what if there was a way to make A and C agree on some kind of common shared secret to compute the pre-image? What it means is if A doesn't, for example, you would the UX would be the same. You have a QR code. You create a payment hash. You display the QR code and you start paying. But C will not be able to actually compute the actual pre-image unless you give it something. If we can get this to work, it means that if A doesn't give that secret to C, even though there's a pending HTLC in its channel, it knows it will never ever lose money, and it's like being able to cancel a payment, and it can start paying again. This, I think, is pretty hard to do with hashes and pre-images, unless you use two different hashes in a payment in the HTLC. But if we switch to private keys and public keys, then what we saw this morning with the way we can combine, you can add private keys and you get the same. Then you can add the corresponding public keys. It's a trick we could probably reuse in Lightning to have payments that could actually be cancelled. What I mean is, first you wait until your HTLC has reached C. C say, okay, I'm all good and ready. Then you give it your secret, and C basically has been paid, and you've paid. If you don't give your secret, you don't pay, and C knows that yes, it has not been paid. So it seems to be fairly good, and switching from hashes pre-images to private key public keys may solve this problem, which in my opinion is the biggest UX problem we have on Lightning. Stuck payments are awful. I don't know if you've explained. If we switch to having some kind of secret that is known by A, that A needs to give to C, you can just, if you see it doesn't work, then you can just go to the website and okay, I cancel it.